In this video, we're talking about finding square roots and comparing real numbers. First, the vocabulary. The square root of a number. In words, if b squared equals b times b equals a, then b is a square root of a. Examples. 3 squared equals 3 times 3, which equals 9. And negative 3 squared equals negative 3 times negative 3, which equals 9. So 3 and negative 3 are square roots of 9. Now let's talk about a real number system. It's broken down to rational numbers such as 1/2, 5/8, 0.37, 0.75, and 2/3. Integers such as negative 10/5. If we divide negative 10 by 5, we get negative 2. Negative 4 and negative 3. And whole numbers such as 4 halves. If you divide 4 and 2, you get 2. 0, square root of 25, which is square root of 25 would be 5, and 6. And our natural numbers, 1, 2, 3, 4, 5. So they're like your counting numbers. And then you have your irrational numbers, square root of 10, which 10 is not a perfect square. Square root of 1.6, square root of 2/3, and negative square root of 123. So there are some examples of some real numbers in the rational number system and the irrational number system. Example 1. Evaluate the expression. Part A, we have plus and minus square root of 36. So 36 is the same thing as 6 times 6, or 6 squared. So square root of 36 is going to plus and minus square root of 36 is going to be plus and minus 6, and we're done part A. Part B, 49 is the same thing as 7 times 7, which is 7 squared. So square root of 49, this time we're talking about the positive one. So this is going to be 7. So this one means positive square root. And we're done. Part C, we have negative square root of 4. So 4 is the same thing as 2 times 2, which equals 2 squared. So negative square root of 4 equals negative 2. In this situation, we're talking about the negative square root. And we are done example 1. Example 2, furniture example. The top of a folding table is a square whose area is 945 square inches. Approximate the side length of the tabletop to the nearest inch. So if we weren't given a calculator, or we didn't have a square root button, what we would do is we would try squaring numbers that we know are possibly 945. So we do 28 squared. That would be 784. So let's see what 29 squared is. So we do 29 squared, that would be 841. So we're getting closer to 945. 30 squared is 900. So that's even closer to 945. 31 squared is 961. And 32 squared is 1024. So we take a look, 945 is somewhere between 900 and 961. So we could say 900 is less than 945, which is less than 961. So the square root of 945 has to be approximately 30 point something. So let's find out what that actually is. Let's use the Desmos calculator to find out what the square root of 945 is. So in our Desmos calculator, we click the keyboard and we just click square root and then type in 945 and enter. And the square root of 945 is 30.74, so we'll round it 2 decimals. And we are done example 2. Example 3, classify the numbers. Tell whether each of the following numbers is a real number, a rational number, an irrational number, an integer, or a whole number. So the numbers we're given is square root of 24, square root of 100, and negative square root of 81. So first and foremost, they're all real numbers. So we know we can just answer yes to all of them. They're all going to be real numbers. So are they rational numbers? So that's where we have to start checking. So to figure out whether they're a rational number, they'd have to have a pattern to the decimal or work out to be a whole number. So let's pull up our Desmos calculator and let's start go to work. So square root of 24. That's 4.898979485557. I don't see a pattern to this decimal, so the first one is not a rational number. But since it does have that pattern that does not repeat, it would be an irrational number. It's not an integer, and it's not a whole number. Okay, let's find the square root of 100. Square root 100, so that is 10. So is it a rational number? Yes, because 10 can be written as 10 over 1. Is it irrational? No. Is it an integer? Yes. Is it a whole number? Yes. Now let's type in negative square root 81. So that's going to give me negative 9. Is it a rational number? Yes, because technically I can write negative 9 over 1. Is it irrational? No. Is it an integer? Yes. Is it a whole number? No, because whole numbers are positive numbers. So hopefully this helps you understand how to classify numbers. And example 4 says graph and order real numbers. So order numbers from least to greatest. We have 4/3, negative square root of 5, negative square root of 13, negative 2.5, and square root of 9. So first, let's number our number line. So we'll start with negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, and 7. So 4/3. We want some decimal approximations to make our life a little bit easier. So 4/3. If we put this in the Desmos calculator, we just type in 4 divided 3, get our decimal approximation. So 4 divided 3 will be 1.3 something. So 1.333. So that's going to be between 1 and 2. So 4/3 we approximately here. 4/3. That one's done. Negative square root of 5. And we'll use approximately equal to. So negative square root of 5 is going to be approximately negative 2.236. Is negative 2.236. And that will be approximately here. So this is negative square root of 5. Okay, next, square root of 13. Go back to Desmos. square root 13, and that's going to be 3.605. So that's approximately equal to 3.605. Let's make sure I read that right. Yes, 3.605. So that's going to be approximately here. So here's square root of 13. Negative 2.5 is easy. So since we know 2.23, so negative 2.5 should be in the middle. So negative 2.5 is right here. And then square root of 3. Or sorry, square root of 9. Square root of 9 will be 3. So here is my square root 9. So in order, negative 2.5, negative square root 5, 4/3, square root of 9, and square root of 13. And we're done. We have an order from least to greatest. Hopefully this helps you understand how to order real numbers and find square roots and compare numbers.